like
Yeah. No, I got this.
Yeah, that's the exact same one I had.
Yeah, I got it right back. Like,
Don't
don't you do different like quotient? But like
It doesn't always do that.
Like the bottom wasn't square on the answer.
Yes, it was. The bottom's always squared. It's
I know, like
I
on
always
the
went with
answer,
the trash, 'cause I
like it
didn't
didn't.
want
Yeah, the answer.
So this will accept every form. Like if it's just a type in box like this, it'll accept every form of an answer. So like even if it tells you, oh, the answer is this, they're giving you the simplified version. You don't have to type in the simplified version. You can type in any other equivalent version of that. So let's just go through this one. So I want the derivative. First thing is square the denominator. So 1 plus
I actually think I
sine of x squared. Then bring that straight up. So 1 plus sine of x times the derivative of the numerator. So that would be 9 times negative sine, or just write it as negative 9 sine, minus the derivative of the denominator. So derivative of 1 is 0, derivative of sine is just cosine, times the numerator. So times 9 cosine. So again, I'll just write it out like that first, I guess. So I could type that whole thing in, and it should accept it exactly like that. Right? You don't have to simplify it at all. I mean, there are some simple things we could do, though, right? I could make this 9 cosine squared. I mean, I could pull the negative 9 out front, that kind of thing. But it should accept it if you type it in exactly like that. Well, I mean, maybe that's what it would be if we simplified that a lot.
Well, because I feel like I put it in like that.
Yeah, I did that like the first time. You just put it in and like put the 9 over 1.
Wait, say it again. 9 over,
12 plus 9.
just like without.
Yeah.
Yeah, like that's what it was. What is it? No, like I did that and it square. Like it said it was.
So that's just another way of denoting functions. So I mean, we've always said, like we defined some function to be, f of x over g of x. They're just defining those functions to be u and b instead of f of x and g of x. Just another way of writing functions. Yeah, so I mean, on this one, you would have to use quotient rule. Are you okay with that one?
Like cosecant over 1 plus cosecant. It might use the simple things.
Like this one?
Yeah.
Okay. So again, I mean, this would be a quotient rule problem. So square the denominator. So 1 plus secant of x squared. Bring that straight up. Times the derivative of the numerator. So what was the derivative of secant? Secant times tangent.
Oh, you're right.
Yeah. Then minus the derivative of the denominator, so that would just be again secant times tangent times the numerator, which would be times.
So you just type it in like that?
Yeah, you can just type it in
Yeah, I think that was,
like
I
that.
was trying to like combine and do everything.
Yeah, no, I mean you can just type it in like that. I mean it's a lot to type in like that, but I mean, you could just type it in exactly like that.
I forced her to get 100%.
Yes.
on her homework.
I'm like, no, I don't want to type it. I had it. I just don't worry. So if they get certain maybe. But I put in she can attest that I put in parentheses.
Yeah.
I want to see if it gives you.
I type that whole thing.
Yes, I'm curious. Hey,
All right.
I thought I typed it in right. Plus don't put it in
You know,
parentheses.
I never had to put parentheses around the end. I just typed it in secant ends.
Does that work?
Yeah, it works either way. So,
Yeah. Mine. I'm just gonna make it secant squared if that's all right. X. Yeah. Plus secant of X squared. Nice work.
Seriously.
what did I do wrong typing it in?
Yeah, no, I'm emailing Miller to see if I can get one of his unit circles. That has
Oh,
everything on it.
But you're not going to be able to use that.
I can memorize it though.
Yeah, I mean, if you memorize it.
I didn't memorize it last year
I
because
wanna
we
get
didn't
one
need it
in
that
left.
much and we just use it all the time. But if I have it, I can memorize it.
Can you tell me what I want as well?
All right. Any other homework questions?
Kind of.
I watched the
Oh,
Addams
we're up to
Family
30?
yesterday.
Yeah. Yes.
Yeah, I read
I watched the movie.
All right. So the first
It wasn't.
first kind of new thing I want to look at is something like this.
All right. So if we're given a piecewise function like this, we've looked at things like this with limits and continuity, right? But we haven't really talked about things with the derivatives of piecewise functions, right? So first, okay, this first part should kind of be a review to figure out if these two pieces are true. So given this piecewise function, I've got x squared minus 4 over x minus 2 for every x value other than 2. And then it's defined at 1 if x does equal 2. All right, so the first thing we want to figure out is, well, does the function have a limit at x equals 2? How do I figure something like that out? Okay, so if I plug in 2, I get 4 minus 4 over 2 minus 2. I get 0 over 0. So what is that? Right, if we get 0 over 0, that means there's going to be a hole. So is there a limit as x approaches 2?
Just because it doesn't exist.
So what we're really trying to figure out is this problem. Right? Limit as x approaches 2 of x squared minus 4 over x minus 2. So we could do a table. That would be one option. But what was another option if we got 0 over 0? So we can do a little bit of algebra.
Unsquared.
Yeah, so I could factor. We can factor the numerator, right? This would be the same thing as limit as x approaches 2 of x plus 2 times x minus 2 over x minus 2. Now, right, so now we are to a point where we can plug in 2, and what do we get that limit to be? 4. So, does f have a limit as x approaches 2? Yeah, just found it to be 4, right? So that is true. Well, now, how do I figure out if f is continuous?
Since there's a hole, it should be continuous.
So yeah, so there's a hole at x equals 2. But we have that hole, that value defined. Right? So what we're saying, I don't have any idea what this function looks like, but I know at 2, the function is going to 4 from both sides, but the function's value is 1. Yeah, so there's a hole, but the function is defined at x equals 2 to be 1. So is it continuous here? No.
Which
Right?
makes it not.
Exactly. Right? So automatically, if we know the function isn't continuous, we know it's not differentiable either. Right? Because one of our 4 ways of determining whether a function was differentiable was, well, is it continuous? Right? Continuous, corner, cusp, or vertical tangent. Those are 4 places where a function isn't differentiable. Right? So if it's not continuous, it's automatically not differentiable. Right? So the answer here is 1. Now,
The new part then is, well, what if, where is it? Here we go. Okay, so
same type of problem here. And we want to figure out if the limit exists, if it's continuous, and if it's differentiable. Okay, so first, does the limit exist as x approaches 3? This one, the function's slightly different here. We have 2 completely different functions coming from both sides. So how would I figure out if the limit exists here? So that, we want to see if they are equal to each other. That's our goal. Right, so we plug 3 into both of them. So I can say the limit as x approaches 3 from the left, if I plug 3 in here, I get 5, right? And the limit as x approaches 3 from the right, if I plug 3 in here, 12 minus 7 is also 5. So the limit exists. And I'm coming to the same number from both sides. Why is it continuous? Right, so we're saying the limit is the same from both sides, so the 2-sided limit exists, and the function is defined there. Remember, that was our definition of continuity. We're going to the same value from both sides, and the function is defined there. And so after 3 equals 5. So the function is also continuous there. So now the new part. If we know it's both, or the limit exists and it's continuous, how do we determine if it's differentiable there? So the new idea is if derivatives are equal at a certain point, then the function is differentiable at that point. So, what is the derivative of this first part? 1, right? The derivative of this is just 1. What's the derivative of the second piece? 4. Are the derivatives equal at x equals 3? No, they're not equal anywhere, right? It's always 1, it's always 4. So, since my derivatives are not equal, the function is not differentiable at x equals 3. Right? If we think about what's going on here, right, if I've got a line with a slope of 1, and then I've got a line with a slope of 4, it's going to be a corner. Okay? That's what's happening. Right? But using analytical methods, okay, we don't have to know what it looks like. We can just say, well, the derivatives are not equal at that point, therefore the derivative doesn't exist. It's not differentiable at that point. So our answer here would be 1 and 2.
On the AP test, we have to show what come up.
No, you do not have to show word for multiple choice on the AP test. It's just right or wrong. Okay. So any questions on that idea? Okay, so it's a slightly new idea, right? But it goes along with things that we've talked about before. Good with those? Alright. Then let's go back to our trig derivatives from yesterday. Alright, so yesterday we just practiced finding derivatives of trig functions, and we mixed in product rule and quotient rule as well. So today, let's take it one step further and find things like tangent lines and horizontal tangents. Okay, things that we already know how to do. We're just going to apply those, to our trig functions. So let's start with the easy one. Let's say I want you to write the equation of the tangent line to f of x equals sine of x at x equals pi. Okay, so this is an easy one to start with. So what are the two pieces of information I need to write the equation of a line? Point and a slope. Okay. So how do I get either of those? Derivative for slope, so f prime of x is cosine. So what do I do to get the slope at pi? Plug pi into the derivative here. So f prime of pi, cosine of pi. What's the cosine of pi? Cosine of pi is -1. So my slope at pi is -1. What else do I need? A point. So how do I get that? Plug in pi to the, yeah, we want to plug in the x value. So I do value pi. So what's sine of pi? 0. So what I have, to write the equation of my line, I've got my slope is -1 and my point is pi 0. So then we're just using y minus y1 equals m times x minus x1. So we get y minus 0 equals -1 times x minus pi. And we could stop there. But this one's pretty easy to simplify. Y equals -x plus pi. Alright, you okay with something like that? Alright, then let me give you one to try here. Write the equation of the tangent line about x minus cosine of x at pi/2. Okay, write the equation of the tangent line to x minus cosine of x at pi/2. like that. Our slope is 2. Our point is pi over 2, pi over 2. So then writing the equation of the line, we get y minus pi over 2 equals 2 times x minus pi over 2. Yeah, sure. What's that what you got? Questions so far? Alright, let's try one more here. About our original equation is secant. So I want the equation of the tangent line to secant at x equals pi over 4. Pi over 4 is 44. Yes. But, so what?
It doesn't have to be 2
So 1 over something is just the same as its reciprocal, right? So the reciprocal of radical 2 over 2 would be.
Yeah, but then you gotta do the whole like times radical 2. Oh, you don't think do that?
Wait, but you can't write on the denominator.
No, I was not saying like
From now on, you can.
What?
I did-
Yeah,
I
that's
did-
not over.
I did it already.
That's okay if you did it already. But remember, in calculus, any equivalent form of something is okay. So this is perfectly fine. If you want to rationalize it, you can. You can make it 2 radical 2 over 2, which would just be radical 2, right? 2 over radical 2 is the same as radical 2.
Or is 1.
It'll be 1, right? So radical 2 over 2 over radical 2 over 2.
Wait, I'm so confused.
Alright, so secant of pi over 4. Right? You can do it over here. So secant of pi over 4 would be the same as 1 over the cosine of pi over 4. Right? We know that the cosine of pi over 4 is square root 2 over 2. Right? So this is 1 over the square root of 2 over 2. This just means the reciprocal. Right? 1 over something is just its reciprocal. So this is just the same as 2 over radical 2. Now, if you want to rationalize it, it will make this look nicer. Right? If I multiply top and bottom by radical 2, I would end up with 2 radical 2 over radical 2 times radical 2 is just 2. So this is just radical 2. But this is perfectly fine. Right? You don't have to rationalize it. So now, tangents of pi over 4 is just going to be 1, right? Because tangent is the same as sine over cosine. And those values we know. Right? So sine of pi over 4 over the cosine of pi over 4 is just going to be square root of 2 over 2 over square root of 2 over 2. So if I've got something over itself, that's just equal to 1. And so you never have to rationalize anything in here.
Rational.
So what's
Go walk over it. All that. class right now. Tell me what's the right way. Like, so if I'm in the real world and I don't rationalize, I can get like.
Sure. In your career, when are you gonna
I
have to
don't know
rationalize?
because, you know,
I want to go into
In
robotics and I'm doing
College, you're not gonna have to think about it.
You won't. You won't ever have to do something like this by hand in the real world. You'll always have a calculator or a computer. You just have to understand what the calculator or computer is doing.
But it's smarter than this.
No. No, it's not.
I think whoever came up with the letters SEC and TAN.
Alright, so to finish out this problem now, what we have, f prime of pi over 4, secant of pi over 4 we said was just radical 2, and tangent we said was 1. So our slope is just the square root of 2. Or if you want to leave it as 2 over the square root of 2, that's also perfectly fine. Okay? Any equivalent form of something is acceptable. I mean, that's okay.
Just out of habit.
I mean, that's fine. That just that takes a little bit more time, and it also gives you another opportunity to make a mistake. Right? I mean, you could make a mistake somewhere in here. Right? So we kind of want you to not do that work, so there's fewer opportunities to make a mistake.
I'll take less.
All right. So then we also need the actual value. F of pi over 4. So I'm just plugging pi over 4 into secant. So we already determined that secant of pi over 4 was just radical 2. So what we end up with here is my slope is radical 2, and my coordinate point is pi over 4 radical 2. So now writing the equation of a line, y minus radical 2 equals radical 2 times x minus pi over 4. And you can just leave it like that. Okay. Do as little work as possible. Don't simplify things. Don't rationalize things. Just the kiss method. Keep it simple, stupid. Never heard that?
We used it a lot last
Mr. Robert said that all the time.
Pretty sure that was one of the teachers' favorites.
Mr. Robert's math.
Everybody's
Yep.
Yeah. That was so crazy to think about. Like,
What?
really, in kindergarten, we had the same
I have
teacher.
no
Like,
idea.
even up until like 5th grade, we had the same teacher for everything.
Well, I remember like,
Mhm.
lectures
With
with a lot
math.
about science and math, and then just career.
And like, it's just crazy that like they didn't like specialize in it.
I felt like in elementary school. No, now you have
even
to.
now.
I'm gonna take that
all
extra
girl,
time that we
this
have
would
from
be,
not
like, something like all girls
rationalizing to
teachers,
make it
teachers,
simple.
playing charts and stuff like that. Like, and then I got here and Miss Bryan. But like, I don't know why she likes science and math and stuff like that. Oh, and do you know what I mean? Because it always seemed like it's
What
like
does that mean?
Oh, I saw that on the homework. Oh, I think I know this.
Is it the derivative of the derivative?
No, I never got.
Remember that Mr. Wallace had on a pen? And his pants.
I'm done. I'm out cheap.
Alright, so one thing, okay, one thing that we can also take a look at, right, is multiple derivatives.
Yeah, I filled out on the homework yesterday. The example definitely gave me that answer.
No, I definitely just guessed and did similar questions.
That's what I'm saying. Like,
No, like, I literally
I
guessed. I got it wrong in my final check, and then like I saw the answer of it, so then I did a similar question right, and I just picked the one that looked exactly like the one before. But I didn't know what it was.
yeah, Math Excel literally changes one number, but it's usually like a coefficient.
So I just had to.
I don't like that.
So are you telling me that Math Excel isn't real helpful?
No, I love Math Excel.
I hate it.
I like it. I actually do like it.
I
actually
like it.
like the example.
Do you like it because it's easier to get a good grade, or because
Yeah.
it actually helps?
No.
It helps.
Oh yeah,
I hate it because it
It
doesn't
helps you
actually
with
help.
the example.
Yeah, it helps. It like I teach myself with it. Yeah, so like. And
I think they just like
So,
it because it's
Do you feel like you get a better understanding of the concepts from it, or or that you're just getting a good
Oh. It's like,
Well, I mean, if we have a question about it, we ask you. So.
That's true.
I'm getting
did you take off the help me solve this problem?
I did, yes.
I noticed that because I went to do it one day and said, oh, yeah, I can't do it anymore. There was a help me solve. Yeah.
Yeah, but you had to read the problem
Yeah,
anyway.
you went and got it wrong.
Yeah.
I see the example on the show too. Yeah, no, if you do the help me solve it, it'll take you solve it, you get a different problem. I always use the example and I just plug in my other numbers. Yeah, but the example really do help. Yeah, I like it.
Alright.
I just didn't know what I was doing yesterday because I didn't know how to do this.
Alright, so let's take a look at something like this. So we just want to take two derivatives. We want to find the first derivative and then take that derivative. So what is the first derivative of secant? Secant times tangent. So now, how would I take the derivative of this?
Secant tangent plus secant tangent squared.
Yes, because this is a product. Right? I'm multiplying two things together. So we have to use the product rule here. So remember, the product rule, if I define these two functions to be f and g, the product rule is take the derivative of the first, which would be secant times tangent, times the second. Right? So this part here was my f prime, then times tangent. So that's my g, plus the first. So secant. Oh, right. Yeah. Oh, no. No. So yeah, my f is just secant, then times the derivative of
Secant squared.
So the derivative of this is secant squared.
We just have a secant cube there.
Right. Okay, so we could simplify this a little bit and make it secant times tangent squared plus secant cubed. You don't even have to do that. You could stop here, but we wanted to write that out.
I feel like this is gonna be the AP exam because I want to be able to simplify it.
So we want to get in the habit of doing as little work as possible. This is an acceptable answer. Right? The reason is you could mess up going from here to here. Right? You don't need to do that. So
I'm on my feet to mess up. That's what I did. I did the right, simplified version, but I didn't have the right. How did that happen?
yeah.
I don't
I don't
know.
understand that.
No, I had tangent up here, but I didn't have tangent down here. So I have to erase that.
Well, on the AP exam, they would still mark off for that. Like they
Yeah.
look through all of your work. If you had something like that, they would
Oh,
still
well, that's a
take it off.
problem. Yeah, that's okay. So you're telling me if I do wrong version, still pull through with the right answer, they're gonna.
Yes. And we'll
So you're telling me there's no way I'm going to pass these?
no, that's not what I'm saying.
No.
So when we'll start taking a look at the scoring rubrics and everything for free response questions, but
I'll do it too.
generally on all free response questions are worth 9 points. Usually 6 to 7 of those points are work. Like they give you different points for each step of the problem.
Alright,
And only
that's
1 or
also,
2 points
that's
will
also
find
good
points.
if I do my work. Do they give you points for trying your work?
No, not just for trying.
I'm not going to pass this.
They give you points for correct steps along the way. So, like, if you get the first 3 steps right, but then mess up the last couple of steps, you'll still get some points.
Okay,
Still
what
have a
if
chance to pass on
Yes.
it.
And remember, passing is only like 50%,
But you have to get like a 3, don't you?
which is like a 50%.
You said like no one passed on because they.
That's because everybody
tried.
tanked.
Yes. Like, when I say everybody tanked, I mean, like, everybody did nothing for the last month. Like,
That is